In our first section on vectors here, we just learned some of the basics, including how to find a position vector. In this section, what we're going to do is we're going to learn some basic mathematical operations. And it's pretty straightforward. I don't think anything here is going to be too difficult. So if you want to add two vectors, what you do, if vectors are made up of those components, the x and the y, we're just going to add the components. So if I'm doing 3, -2, and the point -1, 4, I'm just going to add the x's, and I'm going to add the y's. Same thing for subtraction. We're just going to subtract the components. So if I started, what they did here is not real clear, but I had 3 and -1, so I'm subtracting those. 3 minus -1 gets me 4, and I've got -2 minus 4 gets me -6. So it's exactly what you would think. Now, I think visualizing it is very difficult, but I think it makes more sense. Like they're showing how you'd put one vector at the end of the second one to add them, and how you would subtract them. What you're actually doing is you're taking the negative version of that second vector. That's what's happening. So again, if you're adding them, you're putting the second vector right at the tail of the first one, and the addition would be where you wind up. Now, if you're subtracting them, what you've done is you've taken the second vector and you've made it the negative version of it, and then you've put that at the tail, and then u minus v in this case would be that new resulting vector that happens from the origin to the end. Do you see what they're doing here? Now, that's what you're technically doing, but I think it's much easier to just think of it as the composite of the different points. How have the x components changed when you've added them? How have the y components changed? And then the same, how have they changed if you've subtracted them? That, I think, makes more intuitive sense. But again, the story is that you're technically adding the second vector to the end of the first vector, or if you're subtracting, you're making the negative version of that vector. But again, that's what's happening, but it's what you do is actually quite simple. It's the composite of the x and the y's. Okay, now, probably in the next section, we'll learn how to multiply vectors themselves. But for now, we're just taking a look at how you would multiply a vector by a scalar, just multiplying it by a single number. So it's just what you would think. What you're going to do is you're simply going to multiply the components. So we see a similar thing. I don't know if we've discussed matrices yet, but if you multiply a matrices by a number out front, you're just going to multiply every component by that value. Well, we're doing the same here. So they want us to find 3 times vector v. Well, I'm just going to multiply the individual components by 3, and I get 9/3. How about 1/2 times the vector? Well, the individual components times 1/2. And then finally, negative v is like multiplying it by -1. It's going to change the values of the components, but just make them both negative. So here's what it would look like, of course. So we're going to change the magnitude there. We cut this one in half, and then this one, reverse direction. It's the same length, but we've now gone in the other direction. Okay, pause this if you want to try, but it's pretty straightforward. We're just multiplying this vector by 3, so we're just going to do that to each of the individual components, and we'd get 15 and 12. All right, so a more complicated one here. They want us to find a new vector, w, that's made up of 3 times u and 2 v's. So if you did this in physics, what you'd really be doing is you'd be putting all of these on top, like starting at the origin and adding 3 of these vectors and then putting 2 v's on it. But as far as the math goes, it's very simple. We're multiplying 3 times u, which we saw was really easy. We're going to get 9, -6. We're multiplying 2 times v, and we get this. Now, we already know how to add vectors together. All we do is add the x components and the y components. And so we do that, we get 7 and 2. Okay, this is easy as well here. So we're finding the components of the vector. Yeah, so this is real intuitive for us after all the trig that we've done. They're just saying, hey, what would be some individual vectors? This v1 is essentially an x vector, and v2 is essentially the y direction. So like This is going to be a big deal in physics. They would call these like the partial forces in each of the directions. You're going to be doing this a lot if you have to take physics. So that's what they're saying. So we have an initial point and a terminal point. So first let's find this position vector. Okay, we saw how to do that. You take the terminal minus the initial for the x and the y, and we get this. So here's the position vector, 4, 2. Well, what part of the vector is happening in the x direction? Well, that's 4, 0. It's all x. What part is happening in the y direction? 0, 2. We basically have just broken this down into its x component here and its y component. That's all. Okay, now a unit vector is a little hard to understand if you're looking at just the pure math of it, but if you think of the idea, it's pretty simple. We want to take that vector and we want to turn it into a vector of degree 1. So we want to cut it down into a piece that just tells us the direction. As far as what the applications of a unit vector are, I'm not sure how it comes into mind, but it's something that we can calculate here. So what we're trying to do, let me show you the picture if I've got one. We're trying to find a unit vector. It's going to have the same direction, but only a magnitude of 1 instead of the entire length of the original vector. Now, if you think of this, let me go back here. If you think of this, I think it will make sense. What we're going to do is we're just going to find the magnitude of the vector, which we knew how to do. So we're doing that here. The magnitude of this vector is 13, just the Pythagorean theorem. Now, wouldn't it make sense if you divided that length by the original vector? Divide the original vector by its length, and now you'd have it in terms of 1 unit instead of whatever it was in. So here's the formula, and let me try to talk you through this again. When you look at this final answer here, it doesn't make a lot of sense what we've done. But if I just find the length of the vector, which is the magnitude, and I divide the original vector by that length, couldn't you see we've now created a unit vector? It's in the same direction, but it's only going to have a length of 1. So let's try that here. So all I'm doing is finding that magnitude. It's 13. I'm going to take that original vector and divide it all by 13. So it's like I'm doing this. It's like multiplying by the reciprocal, 1/13. Isn't that division? It's the same thing. So I would just give him to each of the individual pieces. And that's how I'm getting negative 5 over 13 and 12/13. Okay. Now, yeah, again, this is very similar as well. All we're doing here is we're doing something we've done in trig several times. We're just imagining what would happen if we completed or created a right triangle. What we're going to see is that we could write this, instead of writing a vector like this, like 4, 3 for instance, we're going to write it in terms of its components. And we're going to call the x direction, I don't want to do it like this, sorry, I almost did like an imaginary number. The x direction is going to be I, the y direction is going to be j. So we're going to write a single number that represents the entire vector instead of writing it like this. So pretty simple. So first of all, let's find the position vector. We've got the terminal part and the initial part. Well, we know what we do here is the x component, the terminal minus the initial would get negative 8. And the terminal minus the initial and the y gets us 12. Now, instead of writing it like negative 8, 12, we're just going to write it in terms of I is the x portion and j is the y. And so we would write it like this. Okay, so here's another. So we have the terminal point and the initial point. Let's make the position vector. So we're going to do, we know how to do this. We're going to do the terminals minus the initials. Notice the double negative here. And we're going to get what would have been 3, 4. But instead of writing it like this, we're going to write it in terms of the components, where the I represents the x and the j represents the y. Okay, so let's do this ourselves here. Pause it if you want to try it. Pretty easy though. What we're going to have is 7 minus negative 1. So the terminal, this is going to be the x portion, 7 minus negative 1, and negative 5 minus 6. So the terminal minus the initial. This gets me 8, negative 11. Now that's how we would have written it before, but now we're going to turn it in terms of I and j. Simple. the vector u is going to be 8I minus 11j. Okay, all of that I think is pretty intuitive. Hopefully that made some sense.